As example, we want to investigate integration of a white noise. So in this example, consider that x of t is a white noise. This means that the autocovariance function is described by that. Remember that delta of t is a delta Dirac function, which is 0 for all t, so is equal to 0 for t not equal 0, and at t equals 0 is plus infinity. However, the integral from any interval a to b of delta of t dt is equal to 1 if the interval of a and b includes 0. So if 0 is inside the interval of a and b, it means that a is smaller than b and 0 is between a and b, and is 0 otherwise. So that means that at this point the area under this function is 1 and this function is infinity. So obviously this is the variance at time 2 or at time So for this example, suppose that you give this stochastic process x of t, which is white noise. Give it to an integrator, which integrates from a to time t, and the output is s of t, described by this integral. So then in that case, if we want to calculate the autocovariance of the output, so this is going to be mean of s at time t1 and s at time t2, and then a conjugate on the top of that. This one is integral from a to time t1, and this one is integral from a to time t2. But I'm free to change these dummy variables. So here I put x of 2, d2, and here I put x of nu, d nu. I remember that I have to put a conjugate on this one, and then I have to put expectation. So this guy is equal to, because the dummy variables are different, so here is 2 and here is nu, so I could make this double integral, change the order, and I will get a double integral over 2 and nu respectively from a to t1 and from nu from a to t2, and then expected value of x of 2, x of nu conjugate. Okay, so here I forgot to remove the means. Let us assume that the means are 0. If the means are not 0 in all these expressions, you have to remove the expected value of the involved random variables, and here you will get d2 d nu. And now this guy is equal to this function. We substitute it and then we do integral. So the double integral, because of the delta Dirac function, becomes a single integral. So so if I put the cross covariance inside that, then I get this expression. And now what happens is that I have two variables. I have 2 and I have nu. So let's say a is here, so a should be also here. So I integrate from a to t1 and here from a to t2. So so I have to integrate over this rectangle. So this integral, this area represents this shaded area, which is this inside this rectangle. So once we do this simplification, this delta, because if 2 minus nu falls inside this rectangle, then it becomes simpler. So you can easily simplify, you can work on this integral and see, oh, you are integrating over 2. So if 2 minus nu is in the interval of a to t2, then this integral over delta becomes 1. Obviously, this guy is constant, can come out of the integral. So this is out of the one of the integrals, and you can keep the other integral. So you can simplify that exercise. Please figure it out. What you get here is very important.